All right, guys, welcome back. We got Monday and Tuesday of this week. We're going to do 13.3. This is our last lesson that we need to do. It came official on Friday of what topics are going to be covered on the AP exam. I'll go into that a little bit more at the end of the lesson, but I want to knock out 13.3. And appreciate you guys staying on top of your lessons and getting them turned in. There are some of you guys that need to catch up with that stuff. I'll be in contact with you personally sometime Monday or Tuesday. It's just some things that you guys need to start catching up on because these are the only things I have to go with your grades right now. On a side note, there are many lessons, or not many, but there are some of you guys that are missing some lessons prior to this. With all that's going on, I'm okay if you want grades for those things. If you go back and want grades for those things and go back and do them, and they look like they're done, with effort, not just copying the answers or things like that. If they look like they're done with effort, I will go back and put in grades for you for those topics or those lessons. Exam wise, I need to, sew that up at some point. But again, most important thing for me is to make sure that I get all these topics get to you. We start talking about the AP exam and start reviewing for that thing. So without all that being said, let's get on with this 13.3. And it's basically confidence intervals, two samples, means, and it also throws the paired in there. And so all that's combined in 13.3. Two samples means the difference of confidence intervals along with paired means confidence intervals. Okay. Need to go. So there's the notes. I got those attached to the deal. Here is there. Now, here is the lesson. When I open it up to the PowerPoint, my picture goes away. I don't know what happens there, but we'll just go to town with it. Nope, it doesn't go away. It did go away previously. I got that fixed. All right, here we go. 13.3, estimating the difference between two population means. We're going to jump right in with the conditions. Guys, the conditions are not any different than anything we've done all year. These are going to be really important. Two samples are independently and randomly selected. We're back to independent because we have two independent random samples. Both distributions are approximately normal because either the population is normal, which this one doesn't ever happen. I don't think I've ever seen this on AP. The sample size is greater than 30, or if it's not greater than 30, they're going to give you the data and we'll have to graph it. And then both distributions are less than 10% of the population. Again, that's for to help reduce the chances of multiple samples from the same thing, repetition. Okay, so three conditions that we're going to use, same ones we done. This is my formula. Okay, now remember. Now, I'm going to say that the formula on the formula sheet, guys, you're going to be able to make your own formula sheet. They're not going to know if you have one or not. You're going to be able to use notes and things like that. So, if you want to write the formula down and things like that, again, we'll talk about it later. But this is your statistic, x bar 1 minus x bar 2, your critical value. It is a T because we are dealing with means. And then the combination of the difference, although this is still sum, the difference of the two standard deviations. And in order to do the difference of two standard deviations, we have to take the variance. So we have to square it. We have to square this one, divide them both by n because it's the standard error, then take the square root back out of it. Okay, that's the formula. Again, we'll start talking about that more later. You know that the T critical value is based on degrees of freedom, and the degrees of freedom is this crazy formula that you'll never, ever have to do. You'll never have to show it. Your calculator is going to give it to you. You just write down that value. Don't write down the decimal. Write down the integer, Okay, the calculator will give your DF as two sample means. Two sample means and intervals. I don't know why that it shouldn't say and intervals. Okay. Your conclusion? We are 95% confident that the true difference in population means of whatever in context is between this value and this value. Remember that if they're both positive, we think the first one is bigger than the second one. If they're both negative, we think the second one is bigger than the first one. And if there's one of them negative and one of them positive, then zeros in it, we think there's no difference. Just remember those things. Again, if you're ever asked for the interpretation of the confidence level, that's the one where we talk about in repeated samplings. If we did this over and over and over again, we'd have a lot of different intervals. And all those intervals, whatever percent, will contain the true difference of the means. If this process was repeated several times, many, many times, 90%, 95% of these intervals will produce the true difference in means. Okay? 2010, the Nielsen Company released a report that said women talk and text more than men do. Well, there's a shocker. 2010, and we needed a Nielsen Company to know that. I mean, any moron knows that. All right. This came from 2010, whatever. This statement was based on a collection of data collected by examining random samples of telephone bills selected from two different populations, female cell phone users and male cell phone users. Okay. The report indicated that the mean number of text messages sent per month by a sample of 1,200 women. Let me go over here with my little paper and write this down. N sub W is 1,200, and X bar sub W is 716. That's not 716 out of that. That's the average number of text messages sent with a standard deviation. So I'll do S sub W of 90. Okay. While the mean number of text messages, again, it says mean, so we're not dealing with proportions. The mean number of text messages is sent by month of male, and it's 1,000 of those. So N sub M is 1,000. X bar sub M is equal to 555. And S sub M is equal to 75. So it looks like women do send more text messages than men. They're right at 150, 160 more. But the standard deviation is more for women. So their distribution, this is definitely approximately normally distributed, is flatter, and more spread out, flatter and more spread out. And so there will be some overlap there. And so we want to make sure that zero's not in it. If zero's in it, then we can't say that they do send more. All right, proceed on. What is the average difference of between women and men at a 90% confidence level? And so we're going to use 90%. Okay, that's good to know there. Typically we use 95, but they're going to use 90 this time. All right, check my conditions. We'll just go over here. Let's just go to my paper. Where's it at? I guess I need to just go down here. Where is it at? Bear with me. Where are we? What's going on here? In show. All right, here we go. There's my ladybug. All right, you become big. That's why you weren't there. Okay, conditions. 1, we have 2 independent random samples of men and women cell users. Probably don't need to state all that, but that, again, if this was the AP test, guys, you're only going to get 2 questions. You're only going to get 2 questions. You don't want to leave something out that's going to dock you some points. So this be consistent as we can right here. All right. Second condition, both sampling distributions R approx normal cuz N sub W is 1200, N sub male is 1000, greater than or equal to 30. And that's according to the central limit theorem, according to the central limit theorem. Again, you probably don't need to put all that stuff, but I like to reemphasize some of those things that we've talked about already. Because this is male and female, I'm not going to combine it. You might combine that and say 2200 is less than all cell phone users. You're probably okay there. I'm going to be safe and say that 1200 is less than 10% of female cell users, and 1000 is less than 10% of male. Whoops, not all. There you go. Cell users. It looks like some of y'all's writing anyway. So conditions are met. We're going to do a 2 sample mean T interval. All right. Like to write the formula. Remember, we don't have a ho and a ha here. This is intervals, so we don't have a ho and a ha. X bar women minus X bar men. And if you flip-flop this, it's okay. It's no problem. The instructions did say women minus men. But if you want to flip-flop this and say male minus female, it's not going to change. It's not going to change anything else. Your conclusions and everything else is going to be the same. Plus or minus T square root S squared over N plus S squared over N. We'll put women here and men here. All right. And now we just need to, really, I don't need to plug and chug because I have all the stuff written down right here. Okay. I got it all written down right there. So the one thing I need to do, I'm going to go ahead and do the calculations in my calculator because the one thing I don't have is this T star score. And remember, we got to do a little bit of work to find that thing. So here we go with my calculator. Stat calc test, 2 samp, these are all tests. There's intervals, 2 samp Z, 2 samp T int, right there, 2 samp T int. Enter. I don't have the data, I have the stats. Okay, X bar 1 is the women, that's 716, standard deviation of 90, and a sample size of 1200. Okay, X bar 2 is 555 with a standard deviation of 75. And 1000 is my sample size. We want to do a 90%. We don't want to do a 0.90%. Remember, we never pool. You would only pool if the standard deviations of the population were the same. That ain't going to happen. We don't even know what the population standard deviations are. So always hit no. Calculate. Bam. There it is. And so there's my calculations. DF is, oh my gosh, that DF, did y'all see that? DF is 2190. We'll probably go ahead. We're supposed to say 2197. So let's just say 2197. That should be 2198, but it doesn't really matter. DF is 2197. Interval is 155.21 to 166.79. Yeah, women talk more than men. DF 90%. I would like to see what this T star score is. All right, so we'll do inverse norm stat. No, that's distributions. Distributions. Inverse T, not inverse norm. I said inverse norm. We want inverse T. Right. Area. Now, this is the trick one, right? We don't do 0.9 because 0.9, if y'all remember, right, 90% is the middle. And I want this value right here. My calculator only goes all the way to the left. So I've got to include that little bit right there. And that little bit is 0.05. So I'm going to do 0.95. DF, I'm going to type in that 2197. 97 like we used. Okay, that's why I need to do my calculations first so I can get my DF. 1.646. So that's actually, remember, Z-score is 1.645. In fact, it's probably 1.645. It's not going to matter either way, guys. They're not going to ding you for any of this stuff. 1.645. They'd be happy if you got that. Okay? They're going to say, this cat knows what's going on. If the DF is that big, we might as well use a T distribution. You can go ahead and use a T distribution if the DF is that big. In fact, let's see, where am I at? Here's that formula sheet. And if you go down here to the T scores, those are Z's. Here's my T scores. Notice that here's my DF, right? DF goes up to 1,000, and after 1,000, it uses infinity. Well, this is 2,100, so we might as well use this infinity. And this infinity, there's the 1.645 for 90%. 95, there's a 1.96. 99, 2.576. See, those infinities right there are the same as the Z-scores. Kind of interesting. Okay. All right. We're going to write our conclusion. We are 90% confident that the true difference of means I'm going to say of again, of women, cell users and male cell users is between 155.2 and 166.8. Because they're both positive, it validates that women talk more than men. And we dang sure didn't even need to do any stats for that. I'm just kidding. That's a little humor there. This part, I don't know how much of that we need to say, but that's kind of what the question said. You know, that's what it started off saying. It claimed that women talk more than men. And so I think you probably need to write this. This truly is what it says. This right here, if you told somebody that right there, that doesn't really, that doesn't really explain what's going on. You give me some numbers there, and statisticians would know what you're talking about, but some Larry, Joe, Mo, Curly, and on the street may not know what you're talking about. So if you go this right here, validates that women talk more than men, and you can actually say that women send between 155 and 166 more text messages. That's really what this tells me. Okay. Again, we don't need to stay all that. We're just good right there. All right. Let's go to my PowerPoint. Where did it go? I guess it went away. Where am I at? Right here. All right. Boom. Okay. Approximately normally distributed. I didn't even write as much there. Samples are randomly selected from 2 populations of interest and are independent. 1,200 is less than 10% of all women, and 1,000 is less than 10% of all men. Again, that helps remove the chances of repetitiveness. Method: 2 SAMP T confidence interval. Okay, 2 SAMP T confidence interval. Calculations: degrees of freedom is 2187. Our calculator is going to give us that. There's the formula. Okay, I wrote the formula down. There's the values. Again, I didn't write down the values in my formula because I had all the values. Again, I can't slap over. Excuse me, I'm sorry about that. I can't slap over to that real quick. Here, now I can. I didn't do my values because I had all the values up here. And so, anybody knows, any statistician knows or grader knows, well, there's all your values. So why substitute them in here if you already got them up here? You don't necessarily need to show that, guys. Okay. A lot of the stuff that I used to be a real big stickler about, AP's not as much of a stickler as I am. Okay. As long as you can explain what's going on, you'll be all right. And that's our goal right now. Okay. Got to go back here. I'm sorry about all this bouncing around. PowerPoint. Okay. There's the values. Communicate the results. Confidence interval. You can be 90% sure. I can be 90% confident. The actual difference in mean number of text messages sent. I should talk about sent between women minus men is 155 to 166. That's not very good right there. Both endpoints in this interval are positive. You can estimate that the mean number of text messages sent by female cell phone users is greater than the mean number of text messages sent by male users by somewhere between 155 and 166. Beautiful. So I actually covered my little tush in that point right there. Let's go back, right? If you guys have flip-flopped those, okay, if you flip-flop those by some chance, remember we talked about this. If we flip-flop this, then you would have gotten two negative numbers, and it would have been negative 166 and negative 155. Either way, that would have told me that women speak more than males because the second number is bigger than the first number. And so you would have gotten the exact same thing if you flip-flopped it all. It would have been the exact same conclusion. Okay? So just to make sure we recognize that. All right. Since both numbers are positive, this is validation that women send more text messages than men. Okay? All right. Good enough there. There's another example in the book. I'll kind of walk over that with you when we go, when I look over the book, a part of that, just to kind of show you that part of it. Okay. We'll go right into the match pairs. And again, guys, match pairs, you know what the difference is it's now paired. It's no longer independent. They are dependent some way or another. And it will say there'll be a mean difference as opposed to the difference of the means. Listen to the wording, right? We just did the difference of the means. We took two means and we took the difference of those. In match pairs, we're going to figure out the differences and we're going to take the mean of all those differences. Okay, and if I had my board up here, I'd show you what we're talking about there, but I think you guys did pretty well in my Google question. Right. Appreciate all the ideas for my dinner. No, I'm not eating lettuce. But that was the key word we're looking for there is mean difference. Some of you talked about pairing it up. That's also key what you're looking for, but the words are mean difference if it talks about them. Okay. All right. Conditions. Guys, when you pair it up, it just becomes one sample. It just becomes one sample. So if it's just one sample, those are the conditions for one sample. The samples are random but paired. The distribution of differences is approximately normal because we have larger than 30, which you won't have larger than 30 because we'll have to calculate those differences. You'll have to graph the differences, okay? The population of the differences is approximately normal, and this never happens. I like to say it, but this doesn't ever happen, okay? The number of differences is less than 10% of all the population. I just yawned. I need the stick. I get the stick because I yawned. Okay. Sorry about that. That's what happens when you start doing this pretty late. This becomes one sample again. So X bar, if you want to use the sub D, you can. You don't have to. T critical value, S sub D over the square root of N. Right? It's just one sample. And if it's just one sample, where's my DF? N minus 1. It's just N minus 1 because it's just one sample again. So it's not a real hard formula there. Again, guys, you don't ever have to show it's N minus 1. All you ever have to do is just say DF equals. All right, DF equals. We are 90% confident that the true mean difference, not the difference of the means, mean difference of blankety blank blank is between these two values. Okay. All right. This is the ultrasound that we looked at. I believe this was the same data we looked at for the test. We think that it was higher after the ultrasound than before. If you guys can remember that, you can go back and look on that video, and we'll talk about that. But it's the same data, same information. Wow. All right. So the mean and standard deviation computed from these values, X sub D is that's the mean, and that's the standard deviation. Somebody else brought up a point. One of my students did. I'm sorry. This was interesting. I told you that edit, right? Let's clear all this stuff out here. I'll just do it quickly. Clear all this. Number 4. Bam. Okay. Stat edit. I told you can just go ahead and put the differences in here. What somebody was telling me, and I never thought about this, is you can actually just type in the differences. If it's 6 minus 5, you can do that, and it just gives you that 1. So you can do the mathematical operations. The problem with that, we found out, though, is that if you mess up, you can't really go back and check. You can't go back and see where your mistake was. But that's all right. On the test, on the AP test, you're not going to have to enter data on your calculator. In fact, I don't think you're going to need a calculator at all for anything, because I just don't think you're going to need it. I don't think that tests your knowledge of AP statistics. I think they're just going to give you, they might as well just give you the p-value. And now what's your conclusion? All right, fair enough with that. That way you don't have to spend time punching all that up. We'll talk about that later. I won't talk about it now. Okay. PowerPoint. Okay. Check the conditions. I need to move me. Let's go over here. Okay. Check the conditions. The sample is representative of physical therapy patients. The following box plot of the 7 differences is not too asymmetric. There's no outliers. It's reasonable to think that the population differences could be approximately normal. All right. It would be tough for me to say that that's normal. I think it's skewed a little to the left. But again, all we have to go off of, there's only 7 points. Well, dang, box plot, you need 5 points for a box plot. That's not a very good representation. But that's all we got to go off of. So that's what we're going to roll with. Okay. I don't think I mentioned my 10% rule. 7 is less than 10% of all these individuals, of all surgeries. Okay. I'll come back down over here. All right. Method. We're going to do a paired T confidence interval. It's a paired T confidence interval. The calculations, there's your formula. X bar sub D is T, negative 1.43. We did a 95%. So again, let's go here to my calculator, guys. Go to my calculator. Clear. All right. Distributions. Well, I guess I could have gone to mine. That's all right. Inverse T. Okay. And again, 95%. No, I was wanting a 95. So I want 975. I wasn't doing 90. I want 975. Okay. And DF was 6. And minus 1. Okay. Enter. And there's that 2.45. Okay. If you want to use 244, it's okay. 245. Sorry, there's my calculator. I don't want the settings. Go away. There's how we got that 2.45. Okay. The standard deviation was given to us. All right, it wasn't given to us. We had to punch all that stuff up in our calculator, right? Let's go ahead and make sure we remember how to do that, right? So you're going to have one of these columns with the differences, okay? 1, negative 1, 2, 5, 6, negative 3. Okay, I don't remember. I'm just making those up. Stat, calc, tests, and it's just a T-int. Boom, T-int, because it's just one. You have the data. We'll put it wherever your list is, guys, okay? If your list is in L1 or L2 or L3, okay? And then 0.95. Okay, calculate. Uh-oh. And I messed up because I had L1. I didn't have enough data, and you guys get it. Okay, should have used L3. All right, PowerPoint. Based on these samples, we're 95% confident the actual mean difference, there it is, the average of the differences. It's not the difference of the averages. In range of motion is between -6 and -0.1. Boy, 0 almost got in there. Let's see, we could have made that 99%, because as the level increases, your interval increases, right? Going back to my basketball hoop, right? You were more confident on that swimming pool than you were that basketball goal. We might could have got 0 in there. Again, no big deal. Because both endpoints are negative, we will estimate that the range of knee motion after the ultrasound is greater than the mean of motion than before, somewhere between 0.18 and 6.6. Again, if I change this to 99%, it's very possible that 0 is in there. And if 0 is, we would have said, you know what, I don't think it's greater. Even if it is close, like, it would have been 0.005 or something. But if 0 is in there, we're going to go ahead and say it. All right. That was the paired. Common mistakes. I don't even want to talk about them. We need to start thinking about reviewing. So again, that's all we're going to do here. Let me go to that book real quickly. Okay, here's the book. Some of you said that you're glad that I'm going over this part up too. I should do that during the year. I think we're getting new books next year. Estimating the difference between two populations, confidence interval. So there's the formula in words. That's what you would see on your formula sheet. There it is in the value. Okay, here's the DF. Again, we're not going to use this formula. Don't write it down. Don't do anything with it. Please, please, please don't waste your time with that crap. There's the conditions. They don't use the 10% that much or at all on this. That's just something that they've kind of added lately. So we'll go ahead and stick with that 10% rule. There's a formula. There's a DF again. They're doing it twice. Interpretation of the confidence interval, interpretation of the confidence level. Okay, if you need their stuff. 2 samples. Method is a method you should consider when answer the 4 questions. So that's their stuff that they talk about. I don't use the EMC cubed, and I don't use this stuff. Okay. Here's the same question. It's the exact same information that I looked at. Same data, I believe, 75, 90. All right. There's mu1, mu2. You don't need to define mu1 and mu2. Yeah, we don't know what mu1 and mu2 is, so don't define them. For this example, 90% was selected. Check the conditions. Okay, there's the conditions. There's the calculations. Again, don't do all this for the degrees of freedom. Your calculator is going to give you this value. We expect you to truncate it to that value. So they verified that 187. Okay, there's the T critical value, 1.645, 90%. There's the values. There's the interval. You don't even need to show this one. We need this value right here. Okay. We can be 90% confident the actual difference in mean number of text messages sent is between blank, blank, blank. They should say sent by men minus women. Okay. Both endpoints are positive. You can estimate it. All right. This is software statistical packages, what it would look like. We'll talk about that when we start reviewing. Freshman weight gain. The paper predicted the freshman 15. If y'all haven't heard about the freshman 15, they talk about the freshman 15. When you guys get to college, you're going to gain 15 pounds. Most of the time, for instance, like me, I went to college at 6'1". I got my freshman year, I was 6'3". So, a lot of times it's because you're not done growing. Researchers study random sample simple data weight gain. Okay, here they go. Researchers listed. So here they are on campus, and here they are off campus. Let's see. This is the mean weight gain of those. So on campus, these are the freshmen. If they lived on campus, this person gained 2. I don't think it's anywhere close to 15. 2 of these cats lost. Off campus, This one lost. This one stayed exactly the same. The 15 looks like it's way off according to this data. Mu1 minus mu2, yada, yada, yada. There's the method. There's the check conditions. These samples are random. They weren't big enough to say that it was approximately normal, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's only 10. So I can't say that's approximately normal. We have to graph each one of them. So there's a graph of one of them. There's a graph of the other one. Those both look pretty good. They did them vertically instead of horizontally. Again, no big deal. They labeled them. They did all that stuff. If this was an AP test, you probably want to go ahead and step that out a little bit further. Again, I don't think that's going to be an issue. It's a T. I don't know why they did T test here. There's a 95% confidence intervals between negative 0.9 and 4.0. That right there, it says zeros in it. So because zeros in it, it's hard for us to say there's a difference based on these rules. We can be 95% confident the actual mean difference is somewhere between negative 0.9 and 4 point. Because zeros included that, it's possible there's no real difference in the mean weight gain for students who live on campus and those who live off campus. Okay. And then here's the paired conditions. Okay. And then there's the same knee data. And then if you want to actually look at what it looks like in the actual problem, there that is. Okay. There they're going to go through and do the work. There's that negative 6.6 and that 0.8. Again, you could have flip flopped those, right? We did before and after. We could have done after and minus before. After and minus before, and these would have been positive numbers here. This one would have been a negative. And then down here, I would have just gotten these numbers flip flopped. It would have gone from 0.18 to 6.68. Either way, our conclusion is going to be exactly the same. Exercises. I've assigned you 5 exercises. I'll put those in the thing. All right. So last assignment for the year, guys, out of the book. Last assignment out of the book that we're going to mess with. And then, like I said, after Monday, Tuesday's lessons, we're going to start reviewing for this AP exam. Most of this, guys, is going to be on you. It's on you. You guys get the grade. You guys, it determines your college placement. It determines how much money you're going to save. It means nothing to me. It does. I want every one of you guys to get a 3, 4, or 5. I want everybody to get a 5. But other than that, reviewing, completely up to you. It's all on you. Every one of you have the ability. We'll talk about it Wednesday. I don't want to talk about it now. I've wasted enough of your time. Guys, I appreciate you paying attention to this. All your suggestions have been phenomenal. On my Google Sheet today, I'm going to send it out. Again, do the Google form. That counts as your attendance. That one counts as your attendance. I'm going to put down what times would be best for me to open this up for my office hours, if you will. Some of my students suggested that on Friday that popped on there. If I could just set a time for it. And so I'm going to ask you guys, because I know other teachers do this too, and I'm going to try not to piggyback on theirs, or not piggyback, but not to go at the same time that you do. All right. So anyway, that's going to be one of my questions on the Google form. Fill the Google form out for your attendance. Whether you do the homework or not, I don't care. Do the attendance. Okay. The homework is for your grade. The attendance for to count you present. All right. Thanks for everything, guys. Sorry I wasted a lot of time tonight. I'll talk at you. Somewhere up here I get to stop. And stop.